All right. So 8 in 10 marketing strategies randomly sampled are known to be effective in a banking sector. Calculate the probability that in a sample of 6 marketing strategies employed in the banking sector, none are effective and more than half are effective. So we have to see if this fits the conditions of a binomial distribution. All right. The first one, the experiment involves n identical trials. So these trials, we have 6 trials. All right, 6 trials. All right. Then each trial has to have only 2 possible outcomes. So here, the 2 possible outcomes is either effective or ineffective. Right. So let me just put n equals 6. So the experiment involves n trials, right? There are 2 possible outcomes. In this case, a success, which means strategy is effective, and a failure, which means the strategy is ineffective. All right. Right. So are each of the trials independent of each other? Meaning, if we try one marketing strategy, will it affect the next marketing strategy? No. All right. So each trial is independent of the previous trials. All right. And here the probability is constant. Here the probability is 8 out of 10. 8 out of 10. All right. So this fits a binomial distribution. All right, it fits a binomial distribution. So what we're going to say, and let x be a random variable which represents effective strategies. All right, so you put this x is a random variable that follows a binomial distribution. N number of trials is here 6. We've got 6 trials, and the probability is 8 over 10. Probability 8 over 10. So we can start calculating. On question 1, it asks us calculate that the probability that in a sample of 6 marketing strategies, none are effective. All right, none are effective. Right, so remember x, which represents the number of successes, small letter x, which represents number of successes. So in this case, our number of successes are going to be 0, right? Number of successes equals 0, right? Then we can now put all of this information in our formula. Let me just bring this information down here. Okay, so put this in our formula here. So we're going to say, let me use the board for the formula. So the probability that our random variable x, which is the effective strategies, is 0 equals n c x p to the power x q to the power n minus x. Our probability was already given 8 out of 10, which equals 0.8, okay, which represents the effective market strategies. Our Q, all right, is going to equal to 1 minus the probability, which equals 1 minus 0.8. And we get 0.2, all right. So they told us that if none of the market strategies are effective, so x equals 0. So we compute now, we put into our formula, all right? N represents the number of trials, 6 trials, all right? So we say 6 C 0, all right? Probability 0.8, so times 0.8 to the power 0 times Q, which is 0.2, all right, to the power 6 minus 0, right? So we'll solve these in steps. Let's start with the combination, all right? Number of trials, 6. Number of successes, 0. We say 6 C0. The formula for a combination is n factorial over n. This time we're not using r, we're using x, all right? Over n minus x factorial divided by x factorial. Okay, so we're going to have 6 factorial divided by 6 minus 0 factorial times 0 factorial, not times 0 factorial there. So we're going to have 6 factorial over 6 factorial, and we have 0 factorial, all right? These two cancel each other out, all right? We remain with 1 on our numerator. 0 factorial is also equal to 1, so it will be 1 over 1, which equals 1. All right. 0.8 to the power 0 is just 0.8. It's actually 1. It's actually 1, not 0.8. So here we have 1. 0.8 to the power 0. Anything to the power 0 is 1. All right. Times 0.2 to the power 6. What is 0.2 to the power 6? Hello, what is 0.2 to the power 6? Okay, let me get my calculator then. 0.2 to the power 6. 0.00, 0.00 0.0064. All right. Meaning, so we're going to say 1 times 1 times 0.00064, we get 0.0000064. All right. Convert this into percentage. Okay, in percentage, this is 0.0064%. Okay, so that's the probability that none are effective. All right, that is the probability that none are effective. So let's copy and paste that. We go to part 2, probability that more than half are effective. But we say the probability that more than half are effective. All right, we've got 6 marketing strategies. So half of 6 is 3. Half of 6 is 3. Right. So we're trying to find the probability that more than half are effective. So it's P x, which is greater than 3. Right. So this would be equivalent to probability. And the fourth marketing strategy is effective. Px equals 4 plus the probability that the fifth marketing strategy is also effective, plus x equals 6 plus, oh, not 6, 5 here, 5 here, plus p, the probability that the sixth marketing strategy is effective, plus p x equals 6. Right, so we'll have to solve them each individually. All right, then we'll add them together. So we start with p x equals 4. Let me take it to the board. P x equals 4. All right, so here we're going to have 6 C4 times 0.8 to the power of 4 times 0.2 to the power 6 minus 4. And we solve these individually, so we say 6. And out of 6 trials, 4 are successful. All right. So we say n factorial over n minus r factorial r factorial. Okay, so n is 6, so we have 6 factorial over 6 minus 4 factorial 4 factorial. So we're going to have 6 factorial over 2 factorial and 4 factorial. Right, which is going to be 6 factorial. So the 6 times 5 times 4 factorial. So we get rid of this 4 factorial. These to cancel. Then we remain with 2 factorial in our denominator, which is 2 times 1. Right, so we have 30 divided by 2. That gives us 15. Okay. Excuse me, we have 0.8 to the power 4. 0.8 to the power 4. Point to the power 4 is 0.4096. Then we also have 0.2 to the power 6 minus 4, that is 2. So 0.2 to the power 2 gets 0.04. Zero point zero four. All right, so we can put here, we can say 15 times 0.4096 times 0.04 going to give us 15 times 0.4096 times 0.04. Right, we have 0.24576. So 0.24576, and we'll just say 0.245. All right, that is for the 4 marketing strategies that are effective. So we'll put it here. Now go to probability, right? That the fifth market strategy is effective. And that five market strategies are effective. Right? The probability that five market strategies are effective. Okay, we make and so here it becomes P probability that that five marketing strategies are effective. So this here becomes a 4 here. Okay, then we have 0.8 to the power 5. 0.85, then 0. This will be 6 minus 5 here. All right, so here it's 6 and 5 here. With 6 factorial minus 6 factorial over 6 minus 5 factorial, 5 factorial. And here we're going to have 1 factorial and 5 factorial. All right, so here we're going to have 6, we'll end on 5 factorial. 6 times 5 factorial over, we have 1 factorial All right, so these 5 factorials cancel each other out. So 6 divided by 1 factorial, that's the same as 6 divided by 1. And our answer is 6. Okay, our answer is 6. All right, 0.8 to the power 5. Get our calculator. 0.8 to the power 5. 0.3278. 332. We just end it at 77 here for decimal places. Then we've also got 0.2 to the power 1, which equals 0.2. And we do our multiplications. All right. So we're going to have 6 times 0.3277 times 0.2. Right, so the probability that 5 marketing strategies are effective to be 6 times 0.3277 times 0.2, we get 0.39. We get 0.3932. All right, so that's the probability that 5 marketing strategies are effective. All right, then finally we go to P, the probability that 6 marketing strategies are effective. X equals 6. All right. Px equals x. Back to the board. So here, probability that 6 marketing strategies are effective. So we replace that 5 with a 6 here. Excuse me. All right. So here we have 6. Of 6 here. We have to the power 6. And here we have 6 minus 6. All right, so here it's going to be 6 minus 6. 6 factorial over 6 minus 6 factorial. And we have a 6 factorial here. All right, so we're going to have 0 factorial and 6 factorial. All right, 0 factorial and 6 factorial. Right, the 6 factorials cancel each other out. We have 1 over 0 factorial, which is 1 over 1. All right, which gives us 1. 1 over 1, which equals 2, 1. All right. 0.8 to the power 6. 0.8 to the power 6, we get 0.262. 0.2621. And then 0.20 to the power 0, because 6 minus 6 is 0, gives us 1. So we're going to have 1 times 0.2621 times 1, which gives us 0.2621. Right? Probability that 6 market strategies are effective. All right, so we do the addition here now. Since we've got all the values, so we're going to say So the probability that 4 market strategies are effective, it's 0.04, 0.04 plus 0.3932 plus 0.3932 plus 0.2621. Right. And then we just add 0.04 plus 0.3932 plus 0.2621. So it's 0.6953. So this is the probability that more than half of the market strategies are effective, right? Convert it to a percentage, it's 69%. 69.53%, which can be rounded off to 70%. Yes. All right. We've got part B. Find the expected number of effective strategies, which is the mean. Very easy to find the mean, the expected number of effective strategies, all right, or the expected value, which we call the mean, right? Is just equal to n number of trials times the probability, right? So we have 6 trials, and the probability of the trials being effective was 8/10, which is 0.8. And you're going to say 6 times 0.8. Get 4.8. And then they've asked us also to tabulate standard deviation of the effective strategies. So the standard deviation, sigma, is square root of n times p times q. Right? In other books, you see it like this: the square root of n times p, open brackets, 1 minus q. 1 minus p. Same thing, right? Remember, q equals 1 minus p, so do not panic, right? If you see in other books, it's written like this: 1 minus p. All right, so the number of trials was 6. Probability that the market strategies are effective is 0.8, and our Q is 0.2. So we are going to say 6 times 0.8 times 0.2. 6 times 0.8 times 0.2. You get 0.96. You get the square root of 0.96. It's 0.979. Just say 98 to 2 decimal places. And you are done with the question. And you are done with the question. And you get your marks.